Hey everyone, this is Sindhuja Reddy of BTech second year, BVRIT College, Narsapur. In this presentation, we will learn about stack data structure. So, introduction to stack. A stack is a linear data structure that follows LIFO, which means last in first out principle. The element inserted last is the first one to be removed, which is LIFO. And the operations on the stack are like insertion, push, deletion, pop. And we can say stack as an abstract data type with a bounded capacity, and it is a simple data structure that allows adding and removing elements in a particular order. Every time an element is added, it goes on the top of the stack, and the element that can be removed is the element that is at the top of the stack. So which means like LIFO principle, last in first out principle. Coming to the next slide, we have basic stack operations. The first operation is like push. Push means adding element to the stack. Here we have push X. Here we will do like add element X to the top of the stack. And we have pop. Remove the top element from the stack, which means pop means removing the element. Next one is peak or top. Return the top element without removing it and is empty. This checks if the stack has no elements and is full. For the fixed size stacks, it checks if the stack is full or not completed. Coming to the next slide, we have implementation of stack. A stack can be implemented using two approaches. They are like array-based implementation and linked list-based implementation. Coming to array-based stack implementation, a stack is represented by a fixed size array. A variable called top keeps track of the index of the last inserted element. Here the push operation is like increment top by 1 and insert the new element at that position. If you want to insert an element into the array, we will increment the top by 1 and will insert the new element. If the top equals to maximum size minus 1, if the top, which means if the top equals to the maximum size of array minus 1, then the stack is full, which we can say that the stack is overflow. And the pop operations we will do like remove the element at the top by decrementing top by 1. We will pop an element by decrementing the top by 1. If the top equals to the minus 1, then the stack is empty, which is like underflow. And the advantage is like the array based stack advantage is like it is fast and simple to implement. And the disadvantage is like fixed size. The stack size cannot grow dynamically, it is fixed. Coming to linked list based stack implementation, a stack is represented as a collection of nodes where each node contains data field to store the element and the pointer which links to the next node. And the top of the stack always points to most recently added node, which means the first node. And the push operation we will do like create a new node and make it point to the previous top and update the top to the new node. And the pop operation is like remove the top node and make the next node the new top. So we'll do like this pop operation. And the advantage for this linked list based stack is dynamic size. Here, dynamic size means no overflow unless the memory is full. And the disadvantage is like slightly higher memory usage due to we are using pointers in this linked list. So the next slide is like applications of stack. We use this in function call stack, which keeps track of active function calls. And the next one is like undo and redo operation in editors and softwares. And expression evaluation like postfix, prefix, and infix conversion we will use stack. And syntax parsing. Compilers use stacks for passing expressions. And backtracking. In maze solving and recursion, we'll use this stack. And browser history management. Going back and forward between pages, we will use this stack to store them. And this slide shows the advantages and limitation. The advantages are like simple and efficient for temporary data storage, and it supports recursive algorithms naturally, and memory management is also easy because which it follows the last in first out order. And the limitations are like limited access. Only top element can be accessible. We cannot access the random elements in the given list or array. And the fixed size in memory implementation, which leads to the overflow of the array. And they're not suitable for random access operations because we can access only the top element. So this is for this presentation. Thank you for listening.